Hello and welcome to the final microprocessor demo. We're going to be demonstrating our ALU and the control circuitry involved in it. So we're going to be performing two operations here. We're first going to subtract the data in ROM 1 and ROM 3. So that's going to be 3 and 1, should give us 2. We're going to be storing it in RAM 7. So we're going to set that to 7. We're going to be subtracting 1 from 3, so that's going to be 1. This is going to be 3, and we gotta make sure select is set to 0, so we subtract, and we'll start it. As you can see, the value 2 is now stored in RAM 7. Now we need to read from RAM 7, and we're going to now shift it left by the amount in ROM 2, and we're going to store that in RAM 5. And we need to make sure this select is set to shift left, which is number 4. And now we can run it. And our data is 4 because 2 shift left is equal to 4. That's all for this demonstration right here. The circuit follows a data path control model. Essentially, that's where external signals are brought into a control circuit, and input data is set into a data path, and from the control circuit, that will send control signals to the data path and tell the data circuit what to do with that input data, and that will give output data eventually. And you could even set up so that output data could be more control signals to go back into that control circuit if you want to get crazy. But in this case, right now, we're just manually setting the control. In this example, it's going to be these 3 things right here that tell us what addresses of memory we want to read and write to, and this select model, or select mode selector, to tell us what we want to do with the data being brought in, and obviously the data is what's being stored inside the ROM and the RAM. You could also technically say that our start is control right here. Here are the K-maps and the equations that were made from them. As you can see, we have D1 and D0. D1 is an XOR of Q1 and Q0. D0 is Q prime 0 ANDed with at start or Q1. You'll notice that accumulator out is equal to write. They are the same exact equation, so that makes things simple. Read is equal to Q1 prime or Q0 prime. Clear registers is equal to, this is the most complicated one, clear prime registers is equal to start prime or Q0 or Q1. And our demux is going to equal to Q1. And that is all for this video. Thank you for watching.